Hello, this is a presentation video of a final project for communication and computer network subject. We are from Group 10, consisting of 5 members, which are Ahmad, Samson, Reselda, Ameer, and also me, Saszizita. In networking, during the process of transmission, the frames may be lost, and the mechanism of detecting and correcting this loss is known as error correction. Automatic repeat request (ARQ) is a technique for ensuring accurate data delivery in spite of error occurrence. ARQ provides a reliable transmission of information, and the two main transmission errors include frame injury and frame loss. ARQ is being used as control protocols to fix these errors and can detect lost packet at the sender side using a timer which starts when the packet is sent. In networking, the data link layer is responsible for the flow and error control. These functions are also known as data link control. Flow control refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for acknowledgement. So why flow control is important? During packet switching, it offers an attractive advantages over the more conventional circuit switch scheme, namely flexibility in setting up user connections and more efficient use of resources after the connection is established. However, if user demands are allowed to exceed the system capacity, unpleasant congestions effects occur which rapidly neutralize the delay and efficiency of the advantages that were offered. By using an appropriate set of traffic monitoring and control procedures, which is the flow control procedures, all of those congestions can be eliminated.
Hi, my name is Ahmad. My student ID is 103270. So today I'm gonna discuss the course of this project, communication and computer network. So I have two parts. Gonna be discussed is first part is compare and second part is which best protocol. So for the compare, first one is stop and wait on network condition. So I'm gonna pick the best important explanation is it involves for stop and wait, it involves low and high latency, high error, the performance poor or worse due to some reason such as frequent stalls and extremely inefficient. For go out back end on network condition, for low and high latency, high error shows some moderate performance due some reason such for low latency it shows free transmit entire window and for high latency due to some wasted bandwidth. And lastly, for selective repeat, on low latency, low errors, it shows warning performance due some complete not needed. Now for the part B, for best protocol under specific conditions, for stop and wait, best protocol, only one is the best one is low latency, low error network, for example, wireless. Reason perform well, or I choose it for reason perform poorly in other case, high error rate networks such as Wi-Fi with some single loss packet loss causes retransmission for all subsequent packets in the window, wasting the bandwidth. So for go back end, best protocols is situation where receiver buffer space is limited. Reason perform poorly is very high latency networks such as satellite. Lastly is selective repeat. The best protocol is high latency, high error rate network, such as for example like satellite. Reason perform poorly is memory constraint receiver. So that's all about part A and part B. Thank you for listening.
Next, we move on to the experimental setup for low packet loss, high bandwidth. For this, which is the ideal network, the packet loss probability is set lower than the default value, which is 0.1, and the bandwidth is set higher than the default value, which is 500 Mbps. Then we pick one of the ARQ, which is stop and wait, go back end, and selective repeat. These are the charts for the result. from different scenarios. Now we move on to the high packet, low bandwidth, which is the congested network. The packet loss probability is set higher than the default value, which is 0.5, and the bandwidth is set lower than the default value, which is 50 Mbps. Then we pick one of the RQ, which is stop and wait, go back and selective repeat. So this is the chart for the result of the high packet loss, low bandwidth.
Hi, my name is Reselda with the metric number 106131, and I will continue to present with our last three results. The first one is high latency with different timeout intervals. For high latency with timeout interval 10, the latency is set higher than default, which is 0.5 milliseconds, and the timeout interval is set at 10 milliseconds, and the default is 5 milliseconds. Then we pick one of the RRQ, which is stop and wait, go back and selective repeat. This is the graph shown for timeout interval 10. We have 5 graphs. Next is high latency with timeout interval 15. It is the same as the previous result, but the timeout interval is set at 15 milliseconds, and the default is 5 milliseconds. We also have 5 graphs for timeout interval 15. And the last setup is varying window sizes for go back and also selective repeat. This configuration is only applicable for go back and selective repeat, while all of the network are set in default conditions. And these are the results for go back and selective repeat. This slide shows all of the graphs for go back and selective repeat. We have Windows 5, Windows 10, and Windows 4 for all of the result. And that is all for me. Thank you.
Welcome to Part B, Network Diagram for Narmi Sedan Berhad. This is all of the devices that we use on the network diagram. Justification: single share internet gateway, cost effective and simplified management. The design use one SP connection with a 500 Mbps downlink and 300 Mbps uplink shared between Office A and Office B. Layer 2 inter-office link, cost effective internal connectivity. Offices are via a single layer 2 connection to manage switch, enabling internal communication without routing delay. Firewall between ISP and internal network for the security. Share network resources. Printer and internet are accessible from both offices, preventing unnecessary duplication of resources and increasing equipment costs. Dedicated VLAN for mobile and guest users. Each level use separated wireless access point for employee and guests. With guest Wi-Fi clearly segregated, this prevents unauthorized access to sensitive resources while allowing internet access for visitors. Scalability built-in. Switch-based architecture enables future expansion without a complete redesign, just add more devices to the switch as needed. Conclusion: this provides valuable insight into the performance of various automatic request protocol, stop and wait, go back, and selective repeat under different network conditions. By simulating scenarios with varying packet loss, latency, bandwidth, and window sizes, we gain a comprehensive understanding of how these factors influence throughput, reliability, and efficiency. The analysis to graph and chart allow for a clear comparison of each protocol's strength and limitation. Ultimately, this project enhances our ability to evaluate and optimize reliable data transmission mechanism in real-world network environments. Thank you.